Good afternoon. This is Pat O'Connell. I'm calling to order a special open meeting on grid modernization and integrated distribution planning. It's Tuesday, November 28th at 1:30. The case docket that we're working in is number 22-0089 UT. It's a commission inquiry into rulemaking to implement grid modernization statute. This meeting is hybrid and also available via Zoom. So we have some folks here in the hearing room. And so having called the meeting to order, I will ask Office of General Counsel to call the roll.
Thank you, Mr. Chair. Commissioner Ellison.
Present.
Commissioner O'Connell.
Present.
Commissioner Aguilera.
Present.
All commissioners are present.
Okay, so next item on the agenda is public comment. So is anyone here in person, or did we have anyone register to provide public comment? You okay, Jim?
Mr. Chair, we don't have anyone registered through Zoom, and I'm not aware of anyone in the hearing room who wishes to provide comment.
Okay, I heard you faintly, Patrick. So whoever is controlling the volume, you might want to turn it up if any of the presenters are on Zoom. It might be hard to hear them. So next item then is consideration and approval of the agenda. Pretty straightforward agenda. Turn it over to Commissioner Ellison. And so I'm in agreement with that agenda. How about you?
Yep.
So seeing no disapproval, we're going to proceed with the agenda that we had posted. And so next step is welcome and opening remarks from Commissioner Ellison.
Thank you, Mr. Chair, and thank you to everyone for your participation in this workshop today and your responses to the bench request questions. I understand this is not a great time of year for many of you, and the same is obviously true for us, but I think there's reason for wanting to maintain the forward momentum on this grid modernization, integrated distribution planning effort, so that we can move towards the rulemaking that I think we'd all like to have in place. I do believe that the distribution planning and grid modernization really go hand in hand, and I think we'll really see some of that as we get into some of these details. So thank you again for your responses and participation. I think we'll, if there's no objection, just go ahead and jump into the utility presentations. There's really no particular order here. Would any of the utilities like to go first? You'd like to go first? Okay. PNM would like to go first. That's fine.
Commissioners, you all know me. I'm Mark Fenton, Executive Director of Regulatory Policy and Case Management at PNM. And with me today, Omni Warner. I think you've all met Omni. Omni is our Director of Distribution Engineering at PNM. I always like to say this during these workshops, and it might sound repetitive, but we really appreciate when you're organizing a rulemaking and preparing, you open an inquiry and you're preparing to do a rulemaking, that you've been doing these workshops, because it feels like we're working together towards a rule. So just want to say again, thank you for this informational workshop that we're doing today on grid mod and distribution planning. And we certainly agree with the comments of Commissioner Ellison that grid mod and distribution planning are linked. So we appreciate that. We did file our bench request response last Monday. So if you have any questions about that, I was actually gone, so I don't know that much about it, but Omni certainly does. So we're prepared to answer that. And prior to turning it over to Omni, I'd just like to make a few remarks. PNM is endeavoring to be carbon free by 2040. Energy Transition Act says 2045. Our goal is by 2040. And, oftentimes it's thought about in terms of generation. You think about generation and going carbon free, but, as we embark on this transition, it's certainly becoming very evident that there's several elements to it. There's generation, there's distribution, there's transmission, there's transportation, electrification, there's energy efficiency. There's a lot of elements to it, and you can't do any of them in a silo. So this concept of integrated distribution planning, we're certainly embracing it. And I think Omni today, when he goes through his remarks, will show how we're thinking about distribution planning and keeping the bigger picture in mind. So with that, I'll turn it over to Omni. We sent a presentation out. I think I handed it out to most people, but Judith, I don't know if you have one. I'll bring one over. If anybody needs a copy. Commissioner Aguilar. And as we're going through this, please ask any questions. We don't want it to be just a one-way dialogue. So I know all three of you will do that. So go ahead, Omni.
All right.
Yeah.
Awesome. Thanks, Mark. Thanks for this opportunity. So for some reason, I'm a little bit more nervous today, so I apologize for that. But if you do have questions, please pause me and ask if I'm going too fast or I start rambling too quick. So what I wanted to start with, we'll go to the next slide if that's okay, is maybe just frame up the planning that we do today. So today within our distribution, we have annual plans that we conduct. We look at system loading. We forecast DERs and we plan on each distribution feeder. So the outcome from those studies, we talk about them as contingency plans. So we look at the distribution feeders. We have alternate sources when we need maintenance or outage activities. How do we supply the load for customers during those contingencies? That's part of the annual planning that we go through. So it has forecasts for load growth, but also forecasts for DERs and the generation and that play into it. So the output also from those studies is when we reach capacity in the system, they will trigger area studies. So we'll go to the next slide. Our area studies, we oftentimes think of them more of a 5-year horizon. And so once we do a detailed study, then we're looking at multiple feeders, substations. We're looking at EV and electrification, load growth within areas. But really our primary focus is to make sure that we have a safe, reliable, resilient grid. And then are we building it out so we can consistently serve customers? So within the PNM system right now, we've got about 12 area studies that we're either starting or planning to start on next year. Like I mentioned, those studies might span a period of time of a year and a half of actual study. And then by the time you talk about implementation, they fall into our 5-year AOP planning process. And that's why we really think about them more of a 5-year horizon. So the output from those studies, we can talk about reconfiguration of a feeder. Maybe it's adding actual additional substations or feeders. In some cases, there's reconductoring or reconfiguration of the feeders. So might go to the next slide if that's all right. So the next level of study that we'll talk about here briefly is when we think of these more of customer serving studies. And some of these you've seen or heard about already, but we do DER impacts. So applications for DERs have an impact on the system when they need to be studied in detail. Then we go through the analysis of what's the system impact and the upgrades necessary to integrate those DERs safely and reliably to the system. Okay. Those and maybe just dovetailed with that, and you're probably aware of this, we kicked off a partnership with NREL and Burns McDonnell to initiate in our 568 rule. How do we actually comply with our variances we have? So we think of that in the DER impacts and how can we advance our planning processes. That initiative is actually planned through the tail end of this year, will most likely even fall into the first quarter of next year. The next customer serving study, and this seems to be more and more common upon PNM, which is a good thing for the state of New Mexico. It's a good thing for our service territory as well, is economic development. So anytime customers come to us, and typically they're larger size, then the level of study intensifies based on their interest, but it's really what is the cost to serve new customers. And so we move at the pace that customers want to advance in progression of actually moving to New Mexico or setting up shop in the area. When those studies get beyond a substation, then we involve our transmission group, our generation group in those studies as well.
That brings up a question I had when I was looking through this stuff and your responses to the bench request. Just going back to the previous slide, you mentioned the AOP planning process. So could you explain what that is?
What the AOP planning process? Yeah, so
You mean LRP?
I meant AOP. So approved operating plan. So from a company operation, we look at a 5-year outlay of capital and O&M. And we have more discrete plans inside that 5-year plan. We might look at an LRP that has a little bit beyond the 5-year, but that 5-year plan typically has real projects on the list with prioritization and ranking. So we're, levelizing where we're funding projects and what projects have higher levels of prioritization.
Is that an annually done 5-year plan?
It's refreshed every year for the 5-year look. Yes.
Because then you got to this economic development stuff and how do you change an AOP if you have a new load show up?
And we'll talk a little bit about those a little bit later on, but the short answer that I might be able to give you is most of those projects take some time to develop. And we do have some runway that we've been working through the planning process, and then we weave those into our AOP plan, our 5-year planning process.
And then does your planning process include time for stakeholder engagement, involvement, and then regulatory approval?
They do. And I want to touch on that in more detail too, if I can, but it does. The short answer is yes.
Thanks.
If I could ask about the planning again, you mentioned that you have a 10-year planning horizon for load. Is that detailed load forecasting?
So what we've done, and you're leading me right into some of the next slides a little bit later on, and I'll just touch on it, and then we can dive in a little bit more detail. But we've aligned our distribution plans with what's in our LRP. And so we take the forecast we have there for load, we take the forecast we have for DERs, electrification, and then we apply those. Now, what we are doing at the distribution levels to Hance is the traditional model, and this goes back to the traditional distribution was a one-way energy flow. So you could take those loads and you could almost do a peanut butter spread across your system. And what's the impact across the system? There might be areas that are a little bit higher. But what's occurring now is we need more specificity and location, because location is super important. So we've been working with a few consultants, I say a few because it's been more than one, to determine how to accurately forecast electrification, EV adoption, and DERs in specific areas. And then that information plays into our area planning studies that we're conducting right now when we do the detail.
And then the area detailed planning, is that different from your approved operating plan, or is that part of it?
It would play into our AOP plan. So we would do the area planning studies. The output of the area planning studies tell us that we need to add capacity or reconfigure a feeder or make some system improvements. We'll just call them that. Those projects, we develop the projects to some level of class estimate. So we have level of accuracy. And then at that point, they actually go into our 5-year AOP financial planning. So I think of AOP as a financial planning, area planning as the technical distribution modeling and the asset planning.
And would you do the area detailed planning on all areas, or would it be if if you're projecting some sort of constraint, then you would do that?
It is. So the area plans, they trigger from the annual plans that we conduct. So we wouldn't do an area plan on our entire system. It's more in the areas that we recognize there's a need for capacity or a need for expansion on the system. Some level of improvement is needed to serve customers.
Thank you.
Mhm. So we'll go to the next slide if that's okay. So I like using this slide because I think it gives us a depiction of the transformation. So we've talked a lot about the traditional models, the traditional planning, and I would like to emphasize that we need to continue those type of planning models. That there's advancements that are going to occur with them, but our model really is shifting in the utility space. And so when we talk about the traditional utility, and I like thinking in this way because of just the upbringing in my college education. But the original model was from large generation facilities through transmission down to distribution. And by the time we got to the distribution, it was a one-way energy flow. And we didn't care a whole lot what was going on at the customer interaction because everything aggregated up to a substation. And we could really model it more at a substation and aggregate things together. And that model's shifting. And DERs are really driving a lot of that change. And so it's integration and the tie of generation at the distribution. So we're now turning a distribution system that was a one-way energy flow that had certain aspects and attributes about it to now we have to enhance it to manage two-way energy flow. And so that's really, when we talk about decarbonization, the integration of DERs, all those things play into the advancements that are going on at the distribution level. So we just kind of use this slide to illustrate some of those changes that are going on. Now, I want to go to the next slide just to maybe frame up where we're at with PNM. And I think it's important to understand this. So within PNM, we track the number of customers that have rooftop solar and DERs. So some of these are battery storage as well, that are on the PNM system. Today, we have a little over 41,000 customers that have DERs, or we can say rooftop solar on their premise. That represents 8% of our customer base today. And you can see the trend year over year of number of applications that we've received. We're estimating, and this is where we're going to tie it in to some of our long range plans, but we're estimating that nearly a quarter of our customers by 2040 will have rooftop solar. So it's a significant amount today. It's going to be even larger by 2040. It's going to grow.
And in terms of capacity, how much is that?
You're talking
Currently-
like megawatt capacity?
Yes.
So what we're estimating is roughly 800 megawatts behind the meter by 2040.
And today,
Today we have a little over, you're going to hold me on that number. It's a little over 2,000 megawatts. I'm trying to pull it from memory and I've got a lot of numbers that went through my head. I could look it up exactly and I could tell you the exact number, but I don't have it in my head.
maybe
It's a
200.
little- It's a little over 200 megawatts. So I'm sorry. Yes.
That's okay.
Yes, it's a little over.
2,000s are
Yeah, yes. Yeah, no, thank you. It's like 246 megawatts. So. We'll go to the next slide. So this is a graph right from one of our distribution feeders. And, we talk about reverse power flow. We talk about the duck curve and that's real prominent. If I use that term, is that something you're familiar with? Okay. So this is really our duck curve on one of our distribution feeders. And it's becoming more and more common. So this is real data from our system captured at the substation. And what I'd like to point out is the gray line is the solar production on the distribution feeder. So you see the solar production peaks out at almost 10 megawatts on the feeder. The orange line is the load or the power flow on that distribution feeder. And you can see there are hours in the day that it's reverse power flow, minus 6 megawatts flowing back onto the system. That's back at the substation, okay? So what that tells us is the generation is greater than load. We turn the distribution into two-way energy flow. We have power flowing backwards, okay? So we'll go to the next slide.
Sorry, question on this one. Is this the entire system or
One distribution feeder.
one
That's
distribution?
one distribution feeder. Yep. And then we're going to quantify that a little bit.
And do you have this PNM duck curve for the entire system?
I don't have it aggregated up for all of our system. We have some different data we've been pulling just to try to understand impacts and what's going on, but I don't have that exact graph for all the system. Okay, with me. On the PNM system today, we have 25 feeders that have more than 8 megawatts of solar connected to them. And when we talk about feeders at solar saturation or feeders at capacity, those are feeders that have greater than 90% of the feeder rating has interconnected solar to it. Okay, so it's 25 feeders. That's about that represents about 5% of our distribution feeders. The community solar application is going to add another 125 megawatts at the distribution level. We're estimating it's going to be somewhere between 6 and 10 more feeders that are going to be at solar saturation after we interconnect this community solar projects. The DOE, again, just trying to reference a few things, the DOE defines high penetration of solar as the solar penetration is greater than the min daytime load. What that really means is now you have reverse power on the distribution going back to the substation. If we look at the PNM system, roughly 35% of our feeders have more solar than daytime min load. That's 166 feeders. So for your question earlier, Commissioner, that represents a 35%, a little over a third of our system has reverse power, has that duck curve going on at a feeder level. Okay. So
sorry, I got confused by that. The min load is just net of solar.
Yeah, and we talk a little bit, there's a couple ways we refer to it, but that's the simplest way to think is the net of solar.
Okay.
Correct.
Because I was thinking typically min load's going to be at night.
It is. So it's minimum daytime load. So when we're referring to that, we're referring to it as the minimum daytime load. Okay. Go to the next slide. You can find some of these pictures or illustrations, and we've been using this as kind of our roadmap for our grid modernization. And what I like about this image is it really depicts the technologies necessary to turn the distribution system from a one-way energy flow to a two-way energy flow. And so, you can see the things that we often talk about, the community solar, the distribution batteries, customers with rooftop solar, customers with solar and storage. But in order to accommodate all that, there's other devices on the distribution system. We have to advance our protection schemes. They have to advance. We need automation between distribution feeders, and that we talk about that in the contingency. And so it's the ability to restore service to customers quickly. It keeps the DERs reliable. It keeps reliability for the customers as well. Our circuit breakers, we have to advance the controls, both at the substation and our monitoring of the distribution system. So our modeling and our distribution tools will advance as well. So much more dynamic system, real-time energy flow, energy management. So we'll go to the next slide. So we kind of framed up where we're at with PNM. I want to now give you some insights to what we've done to plan and prepare for this. So what we did at PNM is we actually collaborated with Internex and then Newport Consulting. Newport, you might recognize them, Paul DiMartini. He's often been referenced in DOE presentations and literature that was prepared. So partnering with them, we actually built a guide for a grid modernization implementation plan. And so that guide, it's about 40 pages long. We actually prepared that guide and submitted it with our grid mod application. So it's attached to that application. We leveraged the DOE distribution grid mod volumes. There's 4 volumes in series that kind of walk through the utilities, like how do you plan the grid of the future? What technologies would you need in order to turn a one-way energy to a two-way energy? So we've been using that as a roadmap. We then took that roadmap and said, look, there's going to be new technologies. So move into item number 2. There's going to be new technologies we're going to apply to the distribution system. How do we determine where they're applied, what volume, and what's the cost and what's the impacts? We worked with Burns McDonnell that has experience deploying some of these same technologies and tried to leverage, best practice into our plan. So we built what we call a distribution technology roadmap with Burns McDonnell, and that's a 44-page report. We also attached that one to our grid mod application. So Then the third thing that we felt like we needed to do to kind of put a little more pieces of the puzzle in our plan together is we collaborated with Black and Veatch to build a DER integration plan. So we have high penetration of DERs. We mentioned 35% of our feeders today have greater than min daytime load. So how do you integrate DERs safely, reliably, and increasing resiliency to the system? So we built a mitigation plan with Black and Veatch. That's a 27-page mitigation plan. Now, all of these plans are intended to be refreshed, reviewed. They're not a stagnant plan that we create once, put them on the shelf, and we never touch it again. We, constantly go back and check, and we recalibrate. We check on new technologies, advancements. But we're using them as a roadmap for our planning and our investment strategies and how to advance and modernize the distribution grid.
So that DER plan got attached.
It did. It did. Yep.
That was one of the questions.
It was in this bench request because I think there's relevance to some of the questions that were asked in the bench request. It's also in our cost benefit analysis that we just filed as well, because there's ties in there. So it's supporting and showing kind of some of the background and information around that. So the next few slides, and I won't dive into these too much. I just want to, and we can go through these pretty quick. We'll go to the next slide if that's okay. We basically use those roadmaps, and these are just some pictorial illustrations that kind of show technology stacks. You can see correlations to the DOE grid mod plans, the volume 4. So our technology stack. So this slide actually shows the linkage between the technologies, how they stack, how they interact with each other. And so I won't spend a whole lot of time on that, but you can see a lot of the investments that we've been talking about or that are needed to advance the distribution grid. We'll go to the next slide. This slide came out of the collaboration with Black and Veatch for the DER integration. And so what we developed was mitigation thresholds for DERs. So when DER penetrations hit certain thresholds within the distribution, there's intermittencies that occur on the distribution feeder. So how do you manage those? How do you maintain reliability and safe integration of the DERs? Those are the thresholds of the 35%, 60%, 80%. Those are the percentages of DERs that are integrated to the distribution feeder. So in that forecast, what we did, and we'll flip to the next slide here, is we actually looked at our distribution system. We took the Lori's plan. Thank you. We took our IRP models. Got my acronyms backwards, so thank you. We took the IRP model for forecast. We applied that to the distribution system. We grew the DER integrations on the distribution and said, how much is it going to impact our distribution system? How many feeders are we talking about? And then to what level of penetration? Now, obviously, we don't know exactly where customers are going to integrate those, but it gives us a good feel for what's the level of investment and then where do we need to be prepared. So we actually ran through 3 different scenarios. I don't want to dive too much into this, but we just wanted to show you that we have feeder counts, we have investments, and we went through 3 scenarios. So our base case, which aligns with our IRP model, we did another scenario that's because PNM adoption in solar is about 6.5%. The industry trend is telling us that it could be as high as 13%. So we wanted to say if 13% solar adoption occurs in our system, what's that impact? We modeled that impact across our system. Then the other scenario we went back into is our customer storage adoption is around 6.5%. If we wanted to assume that customers adopt at a higher storage rate than 6%, more closer to an industry standard, then we ran that model to see the impact as well. So we ran through more, call it sensitivity, but several different models to understand the impact of the distribution system. And all of those were looking through the 2040 horizon, like Mark mentioned, which is really our fill goal post to carbon free by 2040. So I'll go to the last slide here. But I mean, hopefully you got a flavor that, a lot of the distribution planning from the annual to the area studies to our DER integration and our grid mod are really aimed to drive how do we safely, reliably, and resiliently build out our distribution system from a one-way energy transfer to a two-way energy transfer. And obviously DERs are impacting, they're not going away, but how do we leverage them for optimization on the distribution they can be leveraged as a tool. So how do we optimize the investment necessary? And I just, reiterate some of the things that Mark had mentioned, but we do believe that the path to carbon free involves DER integration, customer participation. And so I failed to mention it earlier, but when we developed our initial roadmap and the technology roadmap, we did extensive stakeholder outreach, customer surveys to try to gauge like what's important to customers. Is it reliability? Is it affordability? Is it DERs? And the output, we can share a lot of those details with you all. But the general message that we did get is customers are very concerned about reliability, and affordability is right behind that. So we're trying to be very sensitive to, those needs and their interests as well. So I think that concludes. I feel like I've been talking too fast and too much. So I'll pause now and try to answer any questions.
Well, thank you for that. That's very informative. I did want to follow up on a couple of questions in the bench request. One of them was related to sensors in your system and phaser measurement units. And you stated that you currently don't have any at the substations, though. Don't you have some type of sensors that you're obtaining data from?
We do have some sensors at some of our substations. So not all of our we say SCADA controlled. If I say SCADA, is that okay?
Yes.
So some of our substations have SCADA control, and those that do, then we have metering information that's coming back from the substation. And I'll frame it that way. It really is metering type data. It's not down to a millisecond or capturing more on a cycle basis.
So for SCADA, you mean you're able to control some of the switching from your centralized location, but you can also look at voltage levels and instantaneous power flows
at the substation level.
At the substation.
Correct. There's a few devices on our feeder, like at some of our larger solar interconnection points. We have some SCADA points that come back at those, but it's not prominent across our system. It's very spotty at the distribution level. But at the substation level, as you pointed out, or as you asked, we do have that metering information at the substation level.
At all substations.
Not reported back to our central center for all substations, not all of them. So some of them we don't have connectivity because we don't have the communication network that actually is connected to all of our substations.
So you'd have to go around and manually download that data if you wanted to analyze it.
Correct. Like we could put recorders out manually on the feeder, and there's times we have voltage complaints that's exactly what we do. We have a team that would go out and install a recorder, capture the data, and then they have to go collect the recorder and bring it back to the office to analyze it.
Would that be, how much would that cost to do to put some phaser measurement units, say, on at different points on some of these feeders that are experiencing issues?
You're asking me to wing a number off the top of my head that I'm probably not.
I'm just wondering, order of magnitude, is that a huge expense or is that a small expense?
What I would offer is if we have comms there, and that's the if, and there's a lot of areas we don't have telecoms out on our system. And so that's really that's one of the key investments to get the data back, and is having a communication network.
So just putting in the PMUs would sort of be useful, but not completely, because you would have to manually download that data unless you've got some communication system.
Correct. Yep.
Okay. That's very helpful. You did mention about the volt var, integrated volt var controls. What sort of communication system would you envision would be necessary to to realize the volt bar control?
Yeah, so you're asking me something that's a little bit outside of my area, but you know. What I would frame up is that within our grid mod, we had details around our communication network in order to communicate. And that communication was really to support integrated volt bar, Flizzr, and the AMI technologies. And so if you install something like, we call that almost like an underlying technology, then it supports other technologies on top of it. For me to tell you what repeaters, what devices.
I don't need the precise
Yeah.
details of that right now, but okay. All right, thank you.
Yeah.
Sure, if Mark had been here, we provided with cleaning stays.
Oh.
If you can forgive me for that.
But I have some questions following up on something the chair mentioned about stakeholder engagement. So and so I'm focusing right now on slide 12, which is the one that is showing information about the Black and Beach study. And I think trying to frame the question in my head, but I think there are assumptions that you're using and scenarios that you're coming up with and studying. How do you engage or plan to engage stakeholders in those assumptions and scenarios?
Yeah, so maybe there's a couple pieces of that. So one is we look at historical trends. So what has the DER adoptions been? But then we do outreach with there's stakeholders that kind of project what they're anticipating for growth of DER adoptions as well. So, we take those inputs to say, what are we anticipating the growth to look like across the system? When we went through the mitigation, the mitigation is more of if all those DERs are put on the system, then how do we safely and reliably integrate the DERs into the system? So the stakeholder input is probably more in the line of what do we anticipate the growth, maybe where might it occur? We have connections with some of the developers that have been, and so we oftentimes reach out to them. What are they anticipating and seeing trends? So,
Okay. And, as I'm thinking about a rulemaking, that's sort of what I'm thinking about is what assumptions, how are stakeholders involved in the development of the assumptions and the scenarios? What are the sources of information that are being used? I think all of that will be helpful to consider. And then in the mitigation thresholds, I think it's helpful to have a threshold sort of as a basis. But I'm wondering whether it needs to be this strict, like 60% 2-to-1 DER to PNM storage, or is there flexibility in here depending on the feeder?
There is, and we'd be happy to go through any one of the reports in more detail, but those are thresholds or trigger points is the way we're thinking of them. And at that point, then it triggers maybe further evaluation. And then there's, when we put them as thresholds, it was more from like doing a planning of what's the total impact of the system? What's the investment impact necessary to integrate? And then when you get to the actual application, to your point, you would look at specifics of the distribution feeder. And is it applicable, or is there, do you move that threshold a little bit? At what point? So.
Yeah. Okay. And I'm sort of thinking about it in terms of like a broader scope than just this feeder. Maybe it could help the system as opposed to just ensuring the reliability of the system. And thinking about kind of like the duration of the storage that is being installed.
Yep. And when you read the report, if you get a chance to do that, you'll see that we wrote those in, but they're intended to be revisited both as technology advanced, but then as we start deploying the technologies and we get learning. then, some of the thresholds, the sizing, the specifics of, they're not hard numbers, they're not absolutes. So those will change as we advance or as we learn more.
Okay,
So,
great, thank you.
Yeah, I guess just to emphasize something that sounds like we're both thinking about is, especially if you read across all three bench requests, this is a very dynamic environment right now. Not just technology's changing, but loads are showing up. And so, we're seeing interconnection queues for not just generation, but interconnection of substations to add new load also coming to a halt. So then adding more planning and more cycles and rulemaking in there, that's why I was asking about how this stuff can live in the real world, where if investments are needed, they can happen in a rational way that involves stakeholders and gives regulators an opportunity to do their job. So anyway, that's where I was coming from with that. And it really sounds to me like we're in danger of all this stuff folding in on itself if it hasn't already. So when you talk about these plans being dynamic and you're going to update them every year, what happens if the change is quicker than a year?
let me maybe attempt to answer some of that, and then follow up with questions if I don't totally hit it. So what we're seeing right now, and I'll tie it back to supply chain, is many of our pieces of equipment at the distribution level, the supply chain is 18 months to 24 months. So what that's causing us to do at a distribution planning is we have to start thinking in a 2 or 3 year time horizon. And before we invest in buying equipment, we need to have some level of engineering, which means we had to have the planning completed. So we'd go through a planning process, then you do a more detailed engineering, and then you would procure equipment. So now you're talking about a 2 or 3 year horizon by the time you think about something till it's actually deployed. And so if we start adjusting or trying to change the plan in the middle of that, it just disrupts the whole cycle, right? And the end result in delivering a product. So we've had to adjust the way we think internally, largely because of supply chain and how long it takes to get equipment now. If you rewind several years ago, we used to have a lot of that equipment. We were doing the same thing over and over. So we literally would make a plan, we'd pull it right out of our warehouse and we would just go build it because it was the same type of deployment. It was the same equipment we already had in stock and there wasn't supply chain issues. So I don't know if I totally touched on your question, but
my takeaway was the problem is worse than I imagined. Because I mean, if you're saying you have to order stuff 3 years in advance,
at least 18 months
that you're not going to order the wrong thing.
At least 18.
The last thing I want to do as a regulator is charge customers for the wrong thing.
Yeah, that's why we try to think in 5 year plans, and then build that into. I mean, there's some flexibility in those 5 year plans, but that's literally the plan and planning horizon we're starting to think in for a financial planning that's driving our material ordering, things like that. I wasn't trying to scare you.
No, I'm just.
Do you have an answer on ordering the wrong thing?
Well, I don't think that when we look at the technologies and the roadmap we've built, a lot of them are proven technologies. So if you're talking about buying this widget or that widget, I think we have pretty solid plans as to what tools need to be implemented to advance the distribution. And, the technologies that we're proposing to deploy are technologies that have been proven in the industry. So when I'll use the integrated Voltvar, those are technologies improvements that have been demonstrated. It's known. So when we say we're going to invest, we're going to go this way, that's not going to shift the devices or the components we're buying. But it means that we have to start moving in that path if we're going to get a deployment by a certain period of time. So.
And how does all these activities that we're talking about today affect things like the interconnection?
Yeah. So what if we show up in the interconnection and a customer has to upgrade a piece of equipment, or we've got to upgrade something, or there's some asset to interconnect them safely and reliably to the system. If we don't have it in warehouse inventory, then it's going to take 18 months. I'll just use that as a time horizon to order the material, to get it on site. And then there's the construction period that would roll behind it. So that's when we start talking about economic development for customers, if we don't have the transformer, the switchgear, the asset to interconnect them, then that's built into the time horizon in order to serve those customers. So.
I guess once, I was asking about sensors earlier. One question that came to mind is, do you currently have, AMR meters? So, meters that would be digital, that would send a signal, but would require, say, a truck to drive around or a person to pick up that data?
We do not in the PNM that I'm aware of. So I'm not the AMI expert.
You would have digital meters, but they wouldn't be sending out like a pulse that somebody could pick data up,
drive
by.
Correct. Yeah, it actually requires somebody to read. Even the meters that maybe have data collection on them, my understanding is still requiring somebody to actually go by and meter them or collect. The exception is like our substation metering that has data collection that's fed back, which is not, it's typically not at a customer metering quality.
Right.
So,
Okay, thank you. Do you have any other questions? Thank you, gentlemen, for presenting. Okay, would SPS like to go next?
Sure. I even have my voice today. Good afternoon, Chairman and Commissioners. Okay, thank you for the opportunity to talk to you today. SPS does appreciate that the Commission is taking the time to hold these workshops and to work on a rule that is appropriate for distribution system planning and in New Mexico and the issues that the utilities in the state face, especially. As SPS sees increasing load onto its system and increasing electrification of the oil and gas industry and other industries in our service territory, it is going to be necessary to bring on more distribution system planning and to do that build out concurrently. So we're very pleased to be having these conversations with you. When it comes to a rule, SPS is looking for flexibility and balance. A planning process that focuses on modernizing the distribution system in line with the Grid Modernization Act, but that doesn't create a process that slows down the day-to-day business that SPS does to operate and maintain its distribution system in a safe, reliable, and resilient manner. And a process that doesn't slow down the work that's needed to be done to connect customers. And here today with me is Zach Pollock, who I'll introduce in a moment, and he'll be able to answer questions specific to the VentureQuest responses and about our overall policy thoughts when it comes to distribution system planning. Also, there's a handful of folks on Zoom with me today as well. So if there's anything Zach nor I can answer, we have backup. We can phone a friend. Zach is the Director of Grid Strategy and Emerging Technology for Xcel Energy. He's located in our Colorado office. He has 13 years of experience in the energy sector and has worked with numerous electric and gas utilities as well as infrastructure investment clients. With Xcel Energy over the past 2 years, Zach has led Public Service Company of Colorado's first distribution system plan development and was the company's lead for the rulemaking there for distribution system planning. Prior to joining Xcel Energy in 2021, Mr. Pollock spent more than a decade in various consulting, product, and research roles advising utilities, regulators, technology vendors, and investment firms on topics including integrated distribution system planning, interconnection and integration of DERs, non-wires and non-pipes alternatives, and emerging energy technologies. So we are really pleased that Zach is here with us, not only in Excel as a resource for SPS, but here today with us to answer your questions. So thank you, and I'll hand it over to Zach.
Thank you. Good afternoon, commissioners. Yeah, it's a privilege to be here. Echo the comments of Ms. Lees and our P&M colleagues as well. As we think about distribution system planning moving forward, I think Chair O'Connell really nailed it. It's a dynamic environment, something that we really haven't seen historically, aside from a few periods in time when we had rural build out of electric infrastructure after the Great Depression. We saw a little bit of that in the 70s and 80s with increased electric loads, largely due to folks adopting air conditioning and HVAC systems like that. But really, I think about the areas Xcel Energy and SPS serve today. We're being asked to decarbonize multiple sectors of the economy. Right now, primarily in SPS's territory, that's oil and gas load that's electrifying. It's a lot of new economic development that we're being asked to serve expediently by our customers. But not so far off in the distant, New Mexico has very aggressive state policy goals. We're expecting to see rapid dynamic load growth on our distribution system from the electrification of transportation, the electrification of heating. So keeping all those things in mind, I just want to reiterate that we really are seeing a lot more dynamic impacts on our system. And when we think about planning, historically, we've approached it from a generation perspective, that one-way flow of power. We're really planning to the coincident system peak. So effectively, we're creating one forecast. We've got about 400 feeders on our distribution system today in SPS, several more in the works and being built out to serve that load. But that process of being able to serve that load and all those new dynamic requirements upon it, that's something that happens from a bottom up. So understanding the actual loading on each one of those feeders and the substations that they tie to, and being able to analyze that. It also requires, to the earlier comments, understanding where customers are going to be adopting distributed energy resources. And that's something that's new for utilities. We historically have not been in the business of understanding and forecasting where customers are putting those resources on our system, as well as understanding the impacts of those. But at a high level, there's really three foundations as we think about distribution system planning that we hope to bring to bear in this rulemaking. The first is, given all those dynamic changes that we're seeing on our system, there is absolutely going to be a need to build out additional infrastructure to serve that load, whether it's from oil and gas customers, whether it's from transportation electrification, heating electrification, et cetera. As well as being able to support our customers that choose to put in various types of distributed generation. So that's point number one. Point number two, most of the discussion today, at least so far, has focused on, in my mind, what I'd consider capacity expansion. So understanding at the distribution level how our load forecasts impact the need to build infrastructure. There's also a critical piece of evolving our system that requires maximizing utilization of a current infrastructure, as well as extending and maximizing the life and reliability of the things we have on the system today. That's something that often gets buried under the broader mandate of capacity planning, but it is certainly a critical piece of how we plan our system to be able to serve our customers reliably, resiliency, and being able to deal with all those variables moving forward. And then the third piece of that really ties to customer affordability, but given point number one, that we think there is a pretty substantial need to build out infrastructure to meet all those needs, whether they're policy driven or customer driven or some combination of both, we need to be looking at new ways to be able to meet that demand that may not be traditional infrastructure that can help meet those needs in cost-effective ways, really to help mitigate some of the impacts that, left unchecked or unmanaged, those distribution infrastructure requirements would put on our customers from a cost and a bill impact perspective. So didn't have any additional prepared remarks beyond that, but just really want to express our appreciation for engaging with the commission here in this dialogue. Happy to answer any questions and share in some of the learnings we've had from our various other jurisdictions where we operate, as well as my previous experience in consulting, working with other utilities and other state regulators. So thank you.
Well, I'll start off with a question. Given your experience in Colorado as well as consulting to some other jurisdictions. What, in your view, is important when we think about a rulemaking involving distribution system planning?
Yeah, appreciate the question, Commissioner. I think first and foremost, really flexibility. So a framework that allows the company and other utilities to keep up with that dynamic environment. I can say from my experience in Colorado, we focus pretty heavily on the non-infrastructure alternative side of the equation to planning, looking at things like non-wires alternatives. I don't mean to undermine or diminish the value that those might have in distribution system planning, but I think really the focus in making sure that we have a framework and a rule or draft rule that allows us to keep up with that dynamic nature that we're seeing coming from our customers, we're seeing being driven by policies. So beyond that, we look forward to ultimately commenting on what that could look like in further detail, but really the foundational principle for us is flexibility.
Do you, so I understand that you're currently doing, is it 5-year planning?
That's correct. Yeah, the load forecasting process today, again, that bottom up load forecasting process is done on a 5-year basis. We do occasionally look at longer term load forecasts if we have specific customer demands that maybe that. And that 5-year forecasting process is tied to a 5-year capital budgeting process where we ultimately identify, prioritize, and recommend the projects that we'll bring forward.
Is that your process in Colorado as well as in New Mexico, that 5-year horizon?
The capital budgeting process is 5 years, and that's larger a reflection of anything beyond that gets pretty speculative. The forecasting process, though, so the actual load projections, we have gone to a 10-year process in Colorado, and I believe 10 years as well in Minnesota.
Okay, and in Colorado, do you provide your 5-year plans on distribution plans to the commission?
We do. That was driven by a statutory requirement, and then ultimately led to a rulemaking as well.
A question about, your load forecasting. I mean, certainly the 5,000 megawatt shortfall by 2032 is striking, given that your whole New Mexico system is, what is it now, 2,800 megawatts? Or what would you say your current New Mexico system peak is?
Well, if you look at the IRP that we recently filed, showing a 5 to 10 gigawatt need by the end of the decade, that will essentially double our system as it is today. So I think you're in the right ballpark.
Right. And so, and I understand, a great deal of that is going to connect new load in oil and gas distribution. And when you do that, would the oil and gas customer typically pay for the distribution line connecting them to the grid?
So and this is going to me reaching back into my prior role as a regulatory attorney. It depends on the type of connection it is. We have specific line extension tariffs that we follow. So I would refer you to that, and I can definitely get you more information on that. But usually if I'm remembering correctly, not this most current rate case, but the rate case before, we did address that tariff, and there was a sharing provision put into the line extension. So if line extensions to certain customers get used for other customers that come down the road, after it's done, there's a sharing process. But Commissioner, unfortunately, I'm not as familiar with that specific tariff, so I can send it to you.
Because I understand, you have to do all the planning. I just wonder with some of that production load, how long it's there if it's for a limited time frame and I guess you would have to think about that when you're doing your distribution planning.
Yeah, and Zach can definitely certainly talk to this a little bit more. I think I think about connecting specific customers that need to come on a little bit differently from distribution system planning, where we're looking at forecasts and trying to figure out what we need to do in order to make sure that the distribution system as a whole is ready to bring on new load that we see in our forecasts. Zach, if you want.
Yeah, I would agree with that. I mean, we have our obligation to serve. So if there's truly a customer driven load request there, I think we have to honor that. Obviously it gets into some interesting policy questions longer term if that load were to disappear. But I think today, if we have a single customer, multiple customers come to us and request that load, we have an obligation to honor that.
Okay.
And I think that's when in my opening remarks, Commissioner, when I said that there's like the day-to-day business we have to do to maintain and operate and to connect customers. That what we're looking for is not a rule that kind of slows that down, because we need to do it. We have to meet our obligation to serve and maintain the system reliability and safety. But the planning process of, modernizing the system and being sure that we're ready for the new load that we see coming on. I see as apart from that what we need to do every day.
I understand. Thank you.
So I just mostly had curiosity questions when I was reading through your stuff, and then also when I read El Paso Electric's. Are you seeing any fundamental difference between what's happening in Texas versus Mexico in the Delaware Basin?
Well, most of the load growth that we're seeing right now, I think we're seeing in New Mexico. And when you see our IRP, I keep referring to that, we have modeling that shows that. So we show that load growth in New Mexico is rapidly increasing and should be catching up with Texas in terms of the load we serve, making it a 50-50 by the end of the decade.
And then, so that's more just fundamentals in the oil and gas sector, not state line, or is there something else?
Yeah, that's in the oil and gas sector. I'm sorry, I might not be understanding your question, Chairman.
Well, I mean, we're sitting here talking about
Delineated by state line, I
creating
guess.
rules for planning. And then like El Paso submitted a storm hardening plan that they had to submit in Texas, but we're not requiring that here. So clearly requirements are different. I just didn't know if those different requirements make a difference or if it's really economic dynamic bigger than what your Texas regulator and what your New Mexico regulator is doing.
So right now in Texas, the Texas Commission is in the middle of a resiliency plan rulemaking, and Texas does require emergency plans. I'm forgetting what the acronym is specifically, but I think that's what El Paso Electric submitted to you. But I think that the planning that we see on the SPS system as needing, well, the planning that is the dynamic environment that's happening on our system is driven by load growth and not necessarily by the different jurisdictional requirements. Is that what you were asking?
I was just trying to, and then I was going to give you an opportunity to crack on the SPP, but I'll leave that.
Okay. Do you want to comment on SPP? I mean, I don't
know if I have anything else to add there. I was going to make an additional point though. One of the things that we think about in distribution planning is that we're now trying to meet multiple objectives. So we're thinking about how do we do that proactively when we build out the system. And a great example of that, we did this in one of our other recent service territories. We were looking at a design for a single transformer where we'd go in and replace that. We knew based upon our long-term load forecasts, we were going to need a second transformer bank within a few years. So we're starting to make decisions like that where we're upsizing for load that we think is going to be there. We're also looking at opportunities to combine that with resiliency initiatives, whether that's wildfire or storm hardening. So really from an objective perspective, I think a rule that's supportive of achieving those multiple objectives concurrently, I think that really maximizes the use of our capital budget and ultimately minimizes the impact on our customers from a bill perspective.
Thank you.
Oh, thank you for the discussion so far. I did have a question about the planning horizon, which I understand is currently 5 years. And you also receive some 10-year forecasts from some customers.
Correct.
Do you see value in a longer planning horizon? Do you think a longer planning horizon would be more appropriate?
I think 10 years from a distribution system planning perspective is probably the tail end of reasonableness. And I say that again, because it's not like the generation transmission system where we've got a single coincident peak forecast. We ultimately need a forecast for every individual feeder and every substation that forecast rolls up to. So when you take that diversity or multiplicity issue of needing that many forecasts, and then you layer on the what I would consider to be more speculative projections of where customers may adopt EVs or rooftop solar, things that may impact load. When you start to add all those things together, I think beyond 10 years, the value of those forecasts starts to diminish a little bit. I do think there is value in longer term understanding how our IRP forecasts tie out to our distribution forecasts, but in and of themselves, longer than a 10-year distribution planning horizon, I think is a little bit diminishing value.
Okay. And so one of the words that I heard, as SPS was presenting was flexibility. And I'm wondering, can you be more specific? What flexibility do you think is needed?
Yeah, I think when I'm phrasing flexibility or discussing flexibility, really from a process perspective, I can say, having been a part of this process in New York and parts of California, Colorado, Minnesota, frameworks that really allow for more collaborative processes and minimize litigation, I think are probably best suited to achieve the objectives we're trying to achieve in this rulemaking. In my experience in Colorado, we have a fully litigated process there every 2 years. And it feels like by the time we're done litigating the first filing or forecast, it's one, no longer valid, and two, we're already set to file another forecast, another plan. So thinking about both the cadence and the sequencing of these filings or reports, whatever may come out of this rulemaking, as well as the actual procedural aspect of how that is effectuated is sort of what I intended there. More broadly, just the ability for the company to keep up with its day-to-day necessary investments it needs to make, as well as tie in those broader, longer-term investments that are being driven by policy, customer demands, et cetera. So thinking about how we marry those things together in a way that creates efficiencies rather than redundancies and inefficiencies. I don't know if that's helpful.
Yeah, that helps. Okay, thank you.
Thank you.
Great. Thank you very much. We appreciate it.
Thank you, Commissioners.
Good afternoon, Chairman, Commissioners. Hi, I think you all know me by now. I'm Nancy Burns with El Paso Electric Company. And I want to first thank you guys for allowing us to have the flexibility to appear remotely. I'm here by myself today, so our presenter and the people that will be available to ask questions are online. You guys have met Ty Pollard before. He's our manager of distribution systems. I think he gave a presentation or two on reliability metrics and maybe in a prior inquiry. He'll have a short presentation for you this morning. And then we also have a few other people online. If you have any questions about our written answers, Edwin Martinez, he's a project manager for electrification. We have Luisa Reza, she's a manager of regulatory accounting, and Matthew Wallace, he's a project manager for grid modernization. So if you have any specific questions about that, EP also really appreciates the workshop processes that you've set up before we embark on some rulemakings. We're happy to participate in any of the, rulemaking assistance, that staff or the commission may have. We echo a lot of the sentiments of the presentations that have come. Obviously, we have differences. I mean, EP is has a much smaller load in New Mexico than PNM or SPS. But we do have very similar processes, and we're engaged in similar inquiries. In terms of stakeholder processes, we don't have any specific distribution planning stakeholder process right now. We have the integrated resource plan. We have stakeholder processes. We have, we have some transportation electrification planning stakeholder processes that came out from our approved plan. We do energy efficiency stakeholder engagement, and we did get our AMI deployment plan. It was approved through the Grid Mod Act, and pursuant to that stipulated order, we've been engaging in a stakeholder process to develop pilot rate programs. So when I'm listening to the other utilities and thinking about flexibility, the word that really comes to my mind is efficiency and overlapping rule requirements and rulemakings, and trying to, sort of minimize all the concurrent processes that go on. So maybe if consolidation and efficiency, I think it's really important, because there's a lot of work to be done, at the bottom level, at the ground level to build up. So with that, I'll turn it over to Ty. You can see him there. And we've got the presentation up. So thank you.
Can you hear me? Okay. Can you hear me? Hello? Mic check?
The room, because we were hearing the same thing with Patrick Rodriguez earlier in the meeting. So I don't know if somebody from IT is listening. Can you?
I'm sorry. Am I echoing?
Yeah, I think we need a volume adjustment.
Okay.
Yeah.
We can't hear you yet, Ty.
Okay. Okay. Gotcha.
So I guess, we've been at it for an hour, well, more than an hour. So anyway, I'd say let's go ahead and take a 10-minute break so we can run down the audio problems, and it's not you, Ty. It's what's going on here. So yeah, we've got somebody working on it, but I'd still say take 10. We'll be back at 5 till 3. Get a drink of water or whatever.
Mm-hmm.
Hi, are you ready?
Yeah. Are we back?
Okay, I think he's gonna deal with it.
We've got an adjustment, but is it the right one?
Okay.
All right, Mr. Pollard, could you give it a try?
All right. Is this working as expected now over there
It's
for
better.
everybody? Okay. Well, Chairman, Commissioners, thank you again for, having us here today. And again, just echoing everything that the other utilities, were saying. We all look forward to this process, and, I'm ready to see, how this improves. So I'm going to go over our distribution system planning. Next slide, please. Or do I have control? And I'm going to just touch on a few of the responses that we had to the bench request. Our primary objective in our planning horizon. Our primary objective is to provide load growth support and implement reliability improvements that are safe and affordable. And like PNM, we have an action plan horizon of 1 to 3 years with a 3 to 10 year long-term plan. Now, our planning efforts are a little more traditional, I believe, than the other utilities, but if you'd move on to the next slide, please. We provided the fundamental philosophy as part of one of the attachments to the bench request. And I'm not going to go through all of the philosophy, but I'll just hit on some of the major bullet points that we focus on and address. And part of the fundamentals, again, with load growth support is that we really focus on or at the substation power transformer level, as well as the feeder level for our planning efforts. Even though we do take in information from our system-wide efforts and our integrated resource plans, we found that, the system is a little different regionally and locationally. So a lot of our distribution planning efforts focus at those lower levels. And then we do have some ability to perform power flow studies. Now, I put that bullet point in here because, even though we're looking toward advancing, our electrical network is not where we'd like it to be yet, to where we have systems where we can import detailed modeling to perform the different studies that we'd like to. So a lot of our detailed studies are outsourced, or we build crude models by hand, and those are quite time consuming and extensive. So for load growth planning, when we focus on an area for projections, it does take us quite a bit of time to produce those studies. As far as reliability support, some of the bullet points are contingency planning. We do look at providing backfeed support and different aspects of being able to coordinate maintenance efforts, where we need to take different parts or different sections of our distribution network, offline, or move it to different sections for different needs, as well as protection and control elements. Capital investments could be in the form of, communication abilities and, coordinated efforts from fusing to advanced equipment to be able to provide some system support at the operator level. And then again, for power flow studies, again, if we're looking for different types of constraints in our system, then we have to hand build them. So we're a little bit basic at the moment, and we're looking toward advancing a lot of our system abilities and planning efforts. Also, some of our ongoing annual efforts are our system hardening efforts. Those include the cable replacement efforts, as well as pole replacement efforts and things like that. And then we have volt VAR support, and some of that equipment is moderately advanced, but we do provide regulation and capacitive support, different things like that. So if we can go to the next slide, please. Our fundamental load growth planning is that we plan to a 70% threshold. So what that means is that when loads reach 70% of a listed rating, our planning efforts are identified and actions are expected to be complete by the time we reach 80%. After we go beyond that 80%, we're out of the planning efforts and we're more into the urgent system support needs. And so a lot of those efforts don't end up in this portion of our planning activity. One example would be that, our substation power transformer, when loads on a 30 MVA power transformer are projected to reach 21 MVA of additional load, support is planned for completion by that year projected. So if we're projected to reach 21 MVA within 3 years, we have plans to have that particular project completed by that timeline. Of course, a lot of things tend to happen. And projects are delayed. So we have this 10% buffer room for getting the projects completed by the time we reach that 80% mark. At the feeder level, when loads on a 10 MVA feeder are projected to reach 7 MVA, then we have additional facility support planned by that projected year. Now, this doesn't mean that we necessarily need new facilities. It just means that we could perform different types of system switching activities or other types of activities to free up that capacity at that point. And to perform those projections, we use historic loads and trends. And then known large lump loads are also included in the plans. And this is where our large electrification loads like electrified manufacturing or EV loads, different things like that come into us from different elements of the company, and we'll put those projections into our plan. And then, of course, our power flow studies are another tool that we use to support load growth planning. If you could go to the next slide, please. Moving over to reliability, we do have contingency planning, providing backfeed support. We really do attempt to have an N-1 contingency system-wide in the distribution system. Of course, we don't always have that. So in some cases, we're going to have to resort to repairing those facilities during outages to get customers back online. In the protection and control area, we do look at all the coordination, and some projects will develop from the need for more advanced equipment to provide more reliable support and restoration. And then also in protection and control might be projects to add communications to our network where we could provide remote monitoring and control to our distribution operators, to engineering, different elements of the company. And then again, power flow studies, we would use these to identify constraints and voltage issues. And unfortunately, our models are currently constructed manually. Next slide, please. Also under the reliability umbrella are the system hardening plans, pole replacements, typically like for us. Same thing with cable replacements, like for like. Occasionally, we do identify areas that we may need to perform upgrades. So we'll pre-plan to have any efforts in those areas upgraded if we're replacing those types of facilities. And then our Volvar support, we have power quality needs to be maintained within, of course, the required power quality limits, voltage limits plus or minus 5%. There are harmonics and things like that need some attention on occasion. And we do have a limited number of devices installed that could provide power quality monitoring. We're talking on the order of minutes. If we need to go to the level of getting data that is every second or sub-second or sub-cycle, then we would again have to do a PNM does and install power quality equipment and manually retrieve the data as well. Also, our Volvar equipment is all configured locally or operated manually. We do have a radio system that can send one-way signals to some devices. But then again, that's old technology, and we're trying to move away from that. So we prefer to have the local controls. We do have some connectivity to some devices where we can pull data on occasion. Those devices that do have that ability, we typically sample every hour. So we can collect data every hour from some components, recloser controls, capacitor banks, things like that. And then we do have at present, or we have had 2 circuits that have had high PV penetration issues. Most cases that resulted in excessively high voltage. Sometimes it was difficult to control. We're still having issues on one of the circuits, but one of them has been resolved. So we're not as far into the DER projections as we would like to be at the moment. But then again, we're not getting as much PV as PNM or SPS in our New Mexico service territory. So we have some areas for improvement on some of our planning efforts. Next slide, please. Oh, that's it. Short and sweet. Sorry, it wasn't more informative, but if you have any questions, we can hope to provide you some responses.
Well, for me, you have the luxury of going last that I ask me questions on the other folks. I just had one similar question on the PNM thing, that distribution system fundamental planning philosophy document. Is that something that was created as for a response to this? I mean, what's the vintage of it? How long has it existed? Those kind of things.
It's existed as long as I've worked for the company, which is 15 years. We've actually adapted it over the years. But it could use some refreshers, some updating and inclusion of some of the newer technologies. But right now, that document has existed.
Yeah, it just didn't have a date on it. So where did this come from?
So just to understand your planning a bit better, you say that you do a 1 to 3 year action plan and a 3 to 10 year long-term plan. Could you elaborate a little bit on your process? Are you refreshing both of those on a annual basis?
Yes, correct. So we do provide updates to the plan annually, and those typically action plan budgets are adapted or streamlined or tightened up to be more in line with the action plans or the system facilities that we're going to be either introducing, upgrading, or whatever actions we're going to be taking at that moment. Anything beyond that is more of a planning placeholder.
You've also said that, when you replace underground cable, you would typically do it like for like, unless there's some engineering recommendation to expand. What would trigger that engineering recommendation? Would it be load growth forecasts, or what would cause that to happen?
Currently, it would be load growth forecasts. Yeah, DER projections would not impact that at the moment.
Okay, potentially electric vehicle adoption expectations could impact that?
Correct, yes.
Okay. I did notice that the amount of the percent of plant in service for distribution at almost 42% of the whole sum is, seems different than the other two utilities. Do you have any thoughts on why it seems to be significantly higher than the other utilities?
I don't think I submitted that response. Do we have the personnel online that responded to that?
Yeah, I understand you may not be able to compare with the other two utilities since you're focused on your utility. But just as a percentage, it does seem to be higher. And I was just wondering if there are any, sort of reasons behind that.
What was that one of the bench request responses? 42% of,
Yes.
okay.
Yes. About 42% of plan and service. That's okay. That's not a critical question.
Thank you. I don't have any additional questions. Thank you for the presentation.
Yeah, I don't think I have any more questions either. Yes, thank you, El Paso Electric for the presentation and for your responses.
All right, thanks.
Thank you.
Okay, so next on the agenda is a public Q&A session. So do we have people that, we've had presentations from utilities and commissioners asking questions. Were there any questions generated utility of other utilities or anybody who's here that had some questions? Okay, so seeing none, I'll turn it back over to Commissioner Allison. It looks like you've got Arthur ready to talk about what's happening next.
Right. So, let me just say I appreciate everyone's answers to the questions and your presentations today. I did detect some concern about what the end result of this rulemaking may be and whether it would limit operational flexibility of utilities. And I can only speak for myself, and from my standpoint, really the intent would not be to interfere with the utilities' day-to-day operations. My thinking is that the utilities do distribution planning. Obviously, it's something that you have to do as a company. I would be interested in seeing the plans, and the reason is that I think it's important to understand whether the plans for distribution planning are aligned with the reliability issues that you're experiencing, whether they are aligned with the grid modernization needs that you're having. I think we will be getting some reliability information as a result of our reliability rulemaking work, which, as you know, is in progress. We have received and will continue to receive grid modernization applications. We will also receive transportation electrification applications. And I think to understand holistically, you know, we also need to have a picture of your distribution planning. So, you know, at least that's, you know, my perspective on why the distribution planning piece is important. And that's, you know, that's apart from my hopes that we would also be providing guidance as to future grid mod applications, you know, what we would like to see in those applications, how will we be assessing those applications. So I do envision future workshops here, and you know, I think it's perhaps a little early to set a date and to describe the exact content of those workshops, but you know, I do see the need to make some progress on the talking about the grid modernization side, and you know, how we would think about assessing future grid modernization applications. Mr. O'Donnell, do you have anything you'd like to add?
Thank you, Commissioner, and other commissioners. I especially want to thank the utilities for elucidating what they are doing now, because it has been a black box for the commission to understand exactly what goes into your planning. I was gratified to hear that that not only are you working on conceptual plans, a few of the reports that PNM identified to me are like conceptual, but actually moving towards a place where you have actionable plans. I was pleased to hear that SPS and El Paso both include a kind of a 3-year action plan, a 1 to 2 year action plan for distribution in one case, and the 3-year action plan. I think that that's really essential, because we can talk about how the industry is changing ad nauseum, but we have to do something about it. And I think it's important for the commission to recognize the drivers behind this need for distribution planning. And it's not just policies that are put into place by the legislature and the governor and the commission, but also consumer demand, consumer preference. I think of all of the statistics that we heard today, the one that stands out to me is that by 2040, PNM is expecting that a quarter of its residential customers will have rooftop solar. I think that that is a remarkable change in a state that has always lagged in terms of economic development. And I hope that we can harness this process in order to make the most benefit out of that. So it's not just allowing people to put rooftop solar and interconnecting them, but to find out what values that can bring to the utility system. We heard talk on a couple of cases of moving from a one-way flow to a two-way flow. That is actually essential. And to me, that is one of the primary drivers of the need for distribution planning, a recognition that consumers really do want to play a role in their own energy future and have some control over it, and actively participate in the utility operations. We're looking at a future that's already being defined in other parts of the country that will harness demand response to help the utility meet their load needs, to help meet peak needs. We're behind in that front, and I see distribution planning as one of the essential ways to bring that into the system in a much more rational way. I also want to reiterate what I've heard a couple of times, especially from Commissioner Ellison, about the interactions between distribution planning, grid modernization, and importantly, the long-term integrated resource planning that utilities are doing. What I hear from the utilities today is that a lot of what you're looking at is load-driven, right? So we want to add not just load-driven, but the types of services that customers want into those projections. And all of that eventually is going to have to go into an integrated plan, a kind of omnibus plan. We're not there yet. It may take a couple of years to do it. So I just want to express my appreciation for the presentations that we've heard today. I agree with Commissioner Ellison that we'd like to see your plans and we'd like to see them on a regular basis. And so that could be a component of a rulemaking going forward. The second element of that is to try, even though we recognize the differences among the utility territories, and there are significant differences, size and geographic territory being presented and types of customers being served, to try and find consistency in the various reports that we get from the utilities. And I think that that's going to be a component of the inquiry going forward into what a rulemaking ought to look like. So we'll look forward to recommendations and suggestions, not just from the utilities, but from other players that will be affected by this in the future. What should the commission most be concerned with to get reports on a regular basis? And how are those reports going to be turned into action plans? For me, that's the crux of any kind of utility planning. And I hope that today we've begun the process that will lead us to something that makes sense for New Mexico. That's all I had to say. So thank you for the opportunity.
Thank you, Arthur. You got a few thank yous in the room here too, but I doubt you could hear them. So anyway, I'll turn it over to Commissioner Aguilera if you have anything you'd like to say before we wind it up.
Well, I'll just echo some of the statements that have been made. And, I think that I agree that thinking about these issues that are related, transportation, electrification, energy efficiency, grid mod, and all of these improvements that are being made and need to be made to the system. It's helpful to think about it collectively in a comprehensive plan. I think we owe it to customers to do that so that we can ensure that the investments that are being made are prudent and not piecemeal. And this is especially important given that, as you've all explained, there's a big transition going on. DRs, excuse me, DRs, two-way flows. We also have the ambitious goal of decarbonizing the grid. And so I think this is a great time to think about how we want to plan our investments. So thank you, everybody, for the presentations.
Yeah, thank you for that. And just what I heard through the workshop and then frankly from the closing remarks also is two things. These workshops are really helpful because I think what we're trying to do is make rules, but recognize that each utility has some fundamental differences. So the workshops are helpful because you get to hear next to each other what's the same, what's different. So hopefully we take advantage of what we're learning here at these workshops when we get to the NOPR stage. And then the last one is just kind of the concept that the old idea of planning was kind of a top down, how do you get from generator to load? We're in a world now where it's more of a bottom up. How are we gonna connect loads to each other so that everyone benefits from the network? So that's just a big paradigm shift. And so instead of like one big lumpy investment, you might have hundreds of relatively smaller investments. So that's not just a shift for the planning that needs to get done, but it's also kind of a regulatory paradigm because the responses we got back really helped me appreciate that question about grid mod filing versus a 440 filing. The answers showed, hey, this is really kind of where the rubber meets the road. So maybe that's something we can think about as we move forward is figure out a way to create something that if a 440 filing happens within a concept that has been stakeholder vetted, regulator approved, it can just happen. But so that's kind of one of my ideas coming out of today. Hasn't been vetted or tested by the process that we have to come. So I'm looking forward to that. So again, thanks for pulling this workshop together, Commissioner Ellison. I agree it was good to keep the momentum going. Also agree we probably won't reconvene in this format till next year. But that's not very far away. So anyway, is it okay if we adjourn? I'm trying to be a kinder, gentler chair, and instead of making that a challenge. You got an objection to, is it okay? So seeing no objection, we're adjourned.
Great.